Beside myself, today I have my colleagues from the members in S522, which is a standardization committee in Denmark about power electronics standards, and we would like to tell you about what potential we think there is in power electronics concerning the green transition, and we hope that you will enjoy this webinar. We'll introduce some specific topics, and I can show them here. This is the overview of the webinar today. So we'll look at 62477-1 and use in risk assessment. Preben Holm from Danfoss will introduce that topic. Norbert Hanigowski will be introducing Ecodesign and energy efficiency of variable speed drives, also from Danfoss. I think I can say that Danfoss is a leading actor in Denmark, and in S522 we have been having Preben and Norbert with us for a long time. They will introduce their specific topics themselves, but also today we have a contribution from Grundfos, Jakob Lønge, which will who will introduce testing of motors and associated frequency drives. So you can see that we're talking a lot about today about frequency drives, but it's not going to be all. Jakob Svendsen is also going to be contributing with implementation of standards and labeling schemes. Jakob is from Schneider, so this is a contribution from several big actors in Denmark. At the end of the, as I said before, at the end of the webinar, we'll have a panel discussion, and you can ask questions through the chat. Please write your name and your company and your specific question. I think we can do that in Danish or English, whatever you would like to ask. Normally in our S522 we'll have the language to be Danish, but we decided to have this webinar in English, so we hope that you will spare with us. But it's to have an open webinar for everybody in the society of power electronics in Denmark, and we know there are a lot of international people contributing a lot in the development and all this innovative work in Denmark as well, who is mainly speaking English. So I will shortly introduce what we actually do in standardization, what we do here in Danish standards, where I'm from. I'm Søren Storm, by the way. I'm a consultant in Danish standards. I'm the secretary of S522, who are developing, as I said before, power electronic standards for the international market, together with the rest of the international environment. Our organization are supporting mainly the Danish industry to have possibilities to interact and also to have some new ideas coming into standards who are developed in international society. So we also sell standards and other documents in Danish standards, but they are developed in the international environment, and we contribute to that through our industry. It's an open membership for everybody, so you are welcome to contact me if you need advice concerning potential membership, of course. The idea of this webinar came in this spring of 2021, and we wrote a Danish newsletter about some power electronic standards, and we could see that it has a lot of potential in the green transition as well, And since it's a big topic in around the world right now, we have to emphasize that it's a very important thing to use standards for many reasons. And many of those reasons, that's what our 4 members here are going to introduce today. So if I haven't forgotten anything in the beginning, then I would like to ask Preben Holm from Danfoss to introduce and to take the screen for the first topic.
Thank you very much, Sam, for this introduction to my presentation here. As Søren mentioned, I would talk about the IEC 62477-1 and its use in risk assessment. My name is Preben Holm from Solutions Used team. I've been working at Danfoss since 1995, and as you can see on the screen here, I have quite many activities within the IEC standardization, especially related to safety and also installation coordination. Originally, I'm from Sønderborg Technicum in Sønderborg, where I graduated in 1991, and can say my organization, food supply, safety. Danfoss is a huge company, a global company, and as you can see here, we are split into 3 divisions: Danfoss Power Solution, Danfoss Climate Solution, and Danfoss Drives, where we in these years have a lot of focus on I would talk about the 6 energy savings. Considering Danfoss Drives, we are a manufacturer of frequency converters, drives, and with the merge with the Wacon company some years ago, we have a huge program of frequency drives. Used to be till the megawatt area for many kind of applications, and also grid converters and hybrid and energy storage solutions are today part of our product portfolio. We are looking into a variety of applications where our power solutions are used. You can see here on the screen a lot, both industrial but also commercial. The low voltage directive for a lot of opportunities, but also a lot of requirements for our products, and a lot of things to consider, especially when we are talking about safety. Looking into the future, we have some topics here: digitalization, urbanization, food supply. We are considering climate change, and one thing which is in focus, especially with my presentation today, is the electrification and all those applications where into 62477-1 electrifications seems to be nation protective against electrical shock in these future global megatrends. And this is especially where the 62477 come into has its relevance. I would talk about the 62477-1. I was talking about visual operation modes. It could because one very essential requirement is that we need to produce sufficient safe products in order to not to hurt or kill people or burn down buildings or make other unsafe events. How it used to be. For many years, we have been talking about the low voltage directive. We have been talking about standards, and it seems like we were well aware that we had some essential requirements for protection against hazard in the low voltage directive. On the other side, we also knew that we needed some risk mitigation measures. And for that purpose, we normally are using our product standards. Here are some examples of product standards for power electronics. And the trend or the tendency have been that, well, if things are written in the standards, we have to meet them. If things are not mentioned in the standard, we don't need to take them into account. But essentially, we can then ask ourselves, well, did we actually cover all the hazards associated with our products to ensure that we have a safe product? That's the big question. And that's why I think the risk assessment here comes into its relevance. When we look into the low voltage directive for Europe, it tells us that we are allowed to bring product into the market if it has been constructed with good engineering practice in safety matters. So it does not endanger the health or safety for persons or domestic animals or property when properly installed and maintained and used in application for which it was made. So this safety objects is quite clear. It actually means that no matter how we do, no matter what we do, we need to ensure that we are having a full coverage considering the relevant risk and hazards. So there are to this guideline in IEC a product on the market which do not take into account the hazards and risk which are associated with our product, even though if our standard does not mention anything. So considering the risk assessment, it brings more the standards into a situation where it is a useful tool. It also serves to the purpose that I think we have covered all hazards. The principal elements or the essential requirements of these safe, reasonable, foreseeable issues listed in Annex I of the low voltage directive. When we look into the standard, and in this case, looking into 62477-1, it covers a lot of hazards. It covers protection against fire, electromagnetic force, insulation cotton. If you can see below, there might also be mechanical hazards, environmental impact, and protection against burns and hazard like that. And that's fine. That's good. They are very useful. The issue, the problem, the question you have to ask yourself, well, what are then the relevant hazard, or in addition, what are the relevant hazard of the application and the user behavior? So when I look into how my product is used, I might recognize that there are issues which are not covered by my product standard. It could be severe environmental condition, it could be special operation modes, it could be special event based on user behavior, or it could be misuse by the user. So, fire, temperature, the compliance with the harmonized standard might not always be sufficient to cover the essential requirements depending on the coverage of the standard. So I need to consider, are there additional issues that is the inherent safety when I'm evaluating my product? And this I do by the risk assessment. The second step, essential understanding of risk assessment is, well, I need to understand what are the essential requirement for protection against hazards. Could be from the low voltage directive. I need to identify what are the risk mitigation methods that I can use in order to bring me to a situation where I have a safe product. I need to identify what are the relevant risks and hazards associated with my product. And then I need to select what are the risk mitigation measures which bring me to a safe product. So the risk assessment will help me to identify, evaluate, and find applicable risk mitigation measures for the relevant hazards which are associated with my product. And important is I need to consider it for its complete life cycle. So I'm not allowed to hurt anyone due to my product during the transportation, and also not during the maintenance or installation or whatever. So it is a lifetime which is to be considered. So what are the useful tools for this risk assessment? Well, in Europe, we have this Senelec Guide 32, which is a guide who brings you through the process of a risk assessment. I can say there is a twin to this guideline in IEC. It's a guide 116. And when I look into this guide, Senelec Guide 32 in clause 5, it tells me that I have to begin with to define what are the limits of the low voltage equipment. And these limits are space limits, time limits, other limits. So under which circumstances are my product operating? And this also serves to the purpose that I define as a manufacturer what is the intended use of my product? How is it to be used? And can I identify also some reasonable foreseeable issues? And these reasonable foreseeable issues that can be and on which is sometimes quite difficult to identify. The Guide 32, looking into that, I start with my essential requirements from the low voltage directive. And by the way, if you can see below, there might also be some other regions which are identifying essential safety requirements. Could be, in this example, the Australian or New Zealand standard, or could also be in the US or Japan or whatever. 32 provides me a process to understand the basic principles, the limits, as I mentioned, the hazard identification, the risk identification, risk evaluation, and risk reduction. Or use it for the risk mitigation. When I look into the end of the low voltage directive, this guide, I actually get a quite good list of the hazards that I need to consider. Here you can see electrical, mechanical, EMF, fire, temperature. So it is a quite useful list to use when I'm identifying my risks and hazards. There are some steps which are identified in this guideline. I can use in my risk reduction. The first step is the inherent safe design, which means how can I, by means of the design, make a risk reduction. That could be, in this case, basic insulation, reinforced insulation, could be barriers or whatever. The second step is safeguarding or complementary protective devices or measures. In this case, it could be fuses, circuit breakers. It could be another panel to build the product into. Third step is information for use. So I need to provide the user with information so that he is able to identify any associated risk or relevant risk associated with my product. That's also a measure that I can use. Important is that when I go through these of the product, the way we are using is to reach a level where I have a tolerable risk. I will never go to to a situation where I have 100 try to identify risk at all. That's not possible. Abnormal single fault conditions. Know that from our daily life. It's driving a car is also not 100% safe. So I will have a residual risk which is acceptable. So is it during transportation? As 1, clause 4, 5, and 6 is actually heavily supporting those steps in this risk assessment. So 62477 gives you some methods. We are talking about what is the severity, sure that I can use it in my risk assessment. So when we try to compare our guide 32 and identify what is of 62477, many hours about how to use this. There are quite many similarity in the structure of the standard. So in the clause 4, as I show, we have the design, as you can see on the right side. It is structured in a way that it covers hazards one by one in the standard. It covers the test. It covers the information and marking. So I think it's and I like the standard, and I think that it is well structured and quite easy to follow. Can I solve it by understand how to advise it, or can I cover this, use it in the risk mitigation? And one thing which is very important when we are considering is that always have the focus on what are the type of hazards acceptable for the market. This step here, if we consider that we have a pre-design where we did not consider anything, we can actually look into this as a two-step. We can use the 62477 standard to cover or use it for the risk mitigation, taking into account the elements of the low voltage directive. What are the events that we are facing in the installation? What are the requirements to our product? And how does 62477 cover this? And in the perfect world, the 62477 would cover 100% of these risk. Unfortunately, and that's the case with all standards, we probably need, when we are conducting our risk assessment, also to look into what is not covered by 62477 and then make supplementary protective measures. And step 2 and say, well, how do I find other measures which I can use in my risk reduction of the product? But certainly we are working in the process in the standardization where we try to see the best possible coverage of 62477-1. But as you could see in some of the slides, we have many different kind of applications which give different kind of usage and events that can happen during the installation of the product. The way we are using it at Danfoss is that we have a template here where we try to identify what are the hazards on the normal, abnormal, single fault conditions, the event, the cause, the operation mode. So here we are talking about normal condition, single fault condition, abnormal condition, and then also the product life cycle. So is it during transportation, during storage, installation, operation, maintenance, or dismantling? Then we try to estimate what is the risk. And here we are talking about what is the severity of harm, what is the exposure and occurrence, and what is the possibility of avoiding this hazard. And using the guide 32, we will then bring us to a situation where we can identify what is the risk index. And of course, we could talk many hours about how to use this, and unfortunately, it's not time for that. But that's the overall principle of that. If I go to the next step here, where we still have this hazard trying to harmonize, I have to look into what is the coverage in my standard. In this case, I have been using our product standard for drives, the 2nd edition, the 3rd edition, and try to identify, is the product standard covering the hazards which I need? Yes or no? For your attention. Otherwise, I have to find other measures, as I mentioned. In the next step, I can go in and see, using my standard, and say, well, can I solve the hazard by design? Can I solve it by protective devices, complementary protective devices? Or can I cover this by further information in my manual or marking of my product? And in the very end, hopefully, a risk reduction level which is acceptable for the market, so I can ensure that my product is sufficiently safe.
Preben, du har nået 20 minutter nu.
Yeah. The last things here, just an overview of the 62477. Clause 4 is the design. Clause 4.1 and 4.2 actually give you the high level or fundamental concepts of the hazard evaluation. 4.1, normal use, abnormal use, single fault, reasonable foreseeable misuse. 4.2 is the single fault condition. And then the rest of the clause 4 is actually some deterministic design method that can be used to make a risk reduction due to your design. Clause 5, safety. It's testing, and it's
energy efficiency of variable speed drives.
Design is sufficient made. It also gives me information about if I need some additional design measure or supplementary protective measures, and it also provides me information about, do I need to inform my user by marking. Clause 6, the marking, and in this case I provide information to the user for the selection of the product, for installation, for commissioning, for operational use, and also for maintenance of the PECS. We are looking into many different kinds of power applications where 62477 can be very useful. We have energy generation of renewable energy sources, as you see here. We are also looking into transportation and energy storage, marine, car charging, energy storage, public transportation. The future will bring more, I guess. And we also have the traditional electronic applications where this standard is used or referenced to it. We have drives, we have switch mode power supplies, we have UPS data centers, which are using power electronics very much. Last slide here. We are working on having a global acceptance of 62477. And as you can see here, there are activities around the world which provide information
by 2040.
This standard in.
But let's see how we can.
Within some years, we have a global coverage of the 62477-1, so it can be used globally. Yes. Thank you very much for your attention. And
10%.
Thank you very much, Preben. Preben, you are chair of our national committee. I'm very, very grateful for that. I think risk assessment is a very, very important topic for all kind of products. Anyway, to combine it with the standard is very, very essential for all businesses and all products. So I think it's a very, very important topic you are bringing into to the webinar today. But if we look through S522, we'll see that a lot of different kind of products within the field of power electronics, and we'll continue on
both the system
drives, as Preben was mentioning, and looking into a specific part of the 61800 series, which covers energy efficiency. And we have our expert and also convener of a newly established working group, Norbert Hanigowski, also from Danfoss, which will cover the topic Ecodesign and energy efficiency of variable speed drives today. And this is what we're gonna listen to now. So Norbert, the screen is yours.
Yes, thank you very much, Søren, and I thank all the participants for attending this webinar organized by the Danish National Standardization Group for Power Electronics. My presentation topic is Ecodesign and energy efficiency of variable speed drives. So to start with, the 20% of all the energy we use in the world is electrical energy. And out of this energy, half of all electrical energy is used by electrical motors. So a big share of all electrical energy is used by motors. How can we save energy here? We can do that by adjusting the speed of the motor to the requirement of the application. And this is done with variable speed drives. And by doing so, it's possible to save between 15 and 40% of the energy. Will not run all the time at 30 to 40%. That's a huge number. And there are a lot of applications where the savings are quite significant. Today, 75% of variable speed drives are used in this kind of application, which are pumps, fans, and compressors. So if we would roll out the use of variable speed drive to cover more than it makes sense. 20% of all motors run with variable speed. If we roll this out more, then we would be able to save 8% of all electricity consumption in the world by 2040. These are big numbers, but let's see how we can achieve these numbers. The speed drive mounted on a one levels. If we look at the component itself and we focus on the component, a fluid, you have, let's say, water as a component or the variable speed drive as a component, then the saving potential is about 10%. A much higher saving potential is the use of variable speed drives. That's 30%. That means from the electrical energy we feed, this saves energy. And then the biggest saving potential overall is to approach at system level and to make system and process optimizations. And the saving potential here is 60%. So the biggest saving potential is to have a system level approach. Now, how do we address this? Because many of us know about components. When we buy a fridge, we want to buy an energy efficient fridge or other consumer goods. But how does this look like in the industrial world? Well, this is addressed in a standard for efficiency of motor-driven system, and this standard is IC 61800-9. For standard is that it discusses both the system level approach, but also the component. So you have an all-round picture of the energy saving possibilities. This standard has been published in 2017. It is in Europe, it's harmonized as EN 61800-9, and it has two parts. The first part deals with the extended product approach. The first part discusses the entire system and how to determine if you want more the index of the entire system. That's why the standard is designated as a group energy efficiency publication. Part 2 deals with efficiency determination of variable speed drive and power drive system. So it looks at how to determine the efficiency of a drive, how to classify drives in different efficiency levels. And it also deals with determination of part load efficiency, because if we run variable speed, then of course it's not only important to know what's the efficiency when we run full speed, it's also important to know what's the efficiency when we regulate the speed and reduce the speed. And these are these partial load points. So to start with the first part in the system, the approach proposed in the standard is the so-called extended product approach. And that means that you combine the losses or efficiency of the motor system with the losses or efficiency of the driven system, no matter if it's a pump, fan, conveyor, or whatever. And based on the losses of the extended product, then you can determine the energy efficiency index. And that, of course, is correlated over a given load time duty profile, because the application will not run all the time at 100%, and we need to consider how much time the application runs at which point. Knowing these part load losses of the motor and of the variable speed drive it's essential to calculate this energy efficiency index. And the extended product approach can also be used to determine if for a specific application it makes sense to use variable speed operation, or it makes more sense to still run at fixed speed. Now, to be more specific, I have an example here. What you can see, then the drive would fall in a speed drive mounted on a wall, 50% and elect losses, or turns a pump. So you have a fluid, you have, let's say, water being pumped here, and you have electrical energy to pump this water. So we have this extended product from the 100% torque and to the variable speed drive to the water, the fluid being pumped there. The extended product consists of everything you see in this picture: the pump, the electric motor, the terminal box, maybe even the coupling between electricians. It is needed to, and the losses in the drive efficiency index. Compare the result with a reference we get from the standard, and that of the motor system consisting of motor and variable speed drive, and we combine that with the data of the pump, and for a specific flow time profile, we can determine then the energy efficiency index. And you see, for calculating the motor system, we use the IC 61800-9 standard, and then for the specific application, then there are the respective standardization committees who determine how this is handled for each application. For example, there is the EN 17038 standard for the extended product approach for pumps. So what happens at system level, if you want more information about this topic, you can find this supporting document from there and look what happens in it. It's available for free download and gives more information about the extended product approach for reducing energy into components, how they are classified, what are part load losses, and so on. It is well known that motors are classified in efficiency classes. The classes go from IE1 to IE4 for direct online motors like induction motors, and up to IE5 for motors for variable speed operation. Now, similar to these classes, there are defined 3 classes for drives. The classes go from IE0 to IE2. And also there are defined classes for drive plus motor, so for drive motor systems. And these classes are called IES, and they go from IES0 to IES2. The way these classes are determined is a bit different between a drive and the motor drive system, the power drive system, how we call it, because the definition points are a bit different. For drives, the standard gives a reference value at a point corresponding to 100% relative torque producing current. That's the nominal current of the drive. And 90% relative motor stator frequency, so 90% speed. And then one can compare the reference value with the actual value of the tested drive. And then if the losses of the drive are with 25% higher than this reference, then the drive would fall into category I0. If the drives are 50% less losses, or then the drive would go to a higher efficiency category IE2. Similar for systems, the standard gives a reference value, and then you can compare the actual system with the reference value. The only difference is that the point here, the reference point, is given at 100% torque and 100% speed. The way to determine the IES, if you take one drive and one motor and want to combine them and want to determine the IES, you cannot just say that a IE2 motor plus IE2 drive give a IES2. It is needed to do some calculations. It is needed to look at the losses in the motor, the losses in the drive, add them, and then compare the result with a reference value from the standard, and that will then determine the system efficiency class. Part load losses are especially important because part load losses are what's needed for determining the energy efficiency index. And the standard defines 8 part load loss points, and if you take and you define these points, then you can calculate 75 arbitrary load point by interpolating between the 4 neighboring points. It is also possible to extrapolate. So now with these details about the technical aspects of energy efficiency, I would go a bit more in the political direction and look what happens in Europe. Design directive, the Ecodesign directive in Europe, that's the legislative framework for reducing energy consumption of products. And the way this works is that we have the Ecodesign directive at the top in Europe, and this directive then generate some regulations for various aspects. Among others, the latest regulation is a regulation to digitalization, which I'm very passionate about, leads to major most. It also includes drives. The technical foundation for the regulation are standards, and that means for motors it's the respective standard for motor efficiency, and for drives it's 61800-9-2. The regulation establishes so-called MAPs, that stands for Minimum Efficiency Performance Standards. That means IC 61, a product on the under revision, and the second edition will level. And more specifically for drives, it's the first time ever in the world that drives are regulated in terms of efficiency. So from the 1st of July this year, 1st of July 2021, it is not possible to put a drive on the European market unless it has efficiency class IE2. There are also minimum efficiency requirements for motors. They have been gradually introduced. The current regulation repels the regulation that the former regulation that was valid from the 1st of January 2017 and increases the requirements for the efficiency of motors. So from the 1st of July, there are new
with another
requirement to go to efficiency class I3 for all motors between 0.75 kilowatt and 1 megawatt. Then motors below 0.75 kilowatt down to 120 watt, they also have to meet at least IE2. And then from
many
2023, this will be further extended. And what is remarkable is that
applications where
go to the highest efficiency class for direct online motors to IE4 for motors between 75 and 200 kilowatt. So again, something new and pioneering, which is happening here in Europe. So, in conclusion, there are a couple of trends which drive energy efficiency. Of course, there are the regulation. Of course, there is the political context of green,
which is necessary to
that. We can see an increased focus on total cost of ownership and other similar indicators. Life cycle cost. And this requires a system-level approach and the ability of predicting system efficiency in a standardized manner. Then digitalization, which I'm very passionate about, leads to major opportunities. Let's take this example in the picture. The pump loses efficiency in time because of wear out, falling, sanding, and so on. So in such a situation, the condition monitoring could enable to continuously monitor the efficiency of the pump and then trigger maintenance when the efficiency is dropping. And then, as a final remark, the IC 61800-9 standard is currently under revision, and the second edition will
my presentations. I'm gonna
expected in 2023.
my journey towards standards because I'm rather.
Thank you very much, and I will then answer questions when we have the panel presentation. Thank you. Bye.
Thank you very much, Norbert. That was exactly also what I would like it to say. That if you have any questions, please type them in the chat. Now we have been looking at products from a safety point of view and an efficient point of view. We have Norbert has just increased the scope of a product. This is quite interesting, but that shows that standards in power electronics, they are trying to understand that the application of power electronics is very important for many of the aspects to increase, in this case, efficiency but also looking at in the safety point of view. So when you make a risk assessment, as Preben has been telling about, that you can also look out of the product itself and also look at the scope outside the product itself to make sure that everything fits together. So we have many fields of use for power electronics, and the list is long. And here are some examples, and I've taken the examples where we have some very active Danish standardization committees. They are shown on this list with a letter S. That's just a letter of standardization committee. And they are mirror committees of international committees. And we are not writing the standards in the Danish mirror committees, but we are simply importing the standards, and we are contributing to these standards development in the international committee. And you can see here that, well, we could touch a lot of applications within this power electronic field, and I'm sure that most of you already know quite a bit of them, and maybe also develop power electronics in these different fields. And we are very open to get in touch with you because it is a very important field to have some experience in how are these standards used, what issues are there. I mean, standards are written by people, and with a different kind of angle on the products and so on. I mean, we can just see here, we've now been looking at specific products and also combining products like motors, converters, gearboxes, and so on to make a bigger approach. And there it's important to write standards that covers maybe the joining of different products together, or making sure that you can put these products on the market. And that's also what we're going to touch here at the next presentation. Jakob from Grundfos will explain about his entry into S522. I think this is a very exclusive presentation. I don't think that Jakob has been showing it to everybody else, but it's a very amazing story. Jakob is also going to explain about his work with standards and in the test laboratory, as far as I remember correctly, right, Jakob? That's also what is written on the title. So I would like to welcome Jakob to take over the screen and the video.
Thank you, Søren.
Yes, welcome, Jakob. You're coming through.
Yeah, I should be presenting my presentation as well right now.
Yes, it looks good.
So, well, then let's get started. So my agenda for today is I'm just gonna briefly touch upon who I am. Then we're gonna go through my journey towards standards because it's relatively important to how I ended up in this S522 committee. And then I'm gonna go through Grundfos heat pumps with MGE. Basically there I'm gonna talk a little bit about what testing I've experienced during my job at Grundfos. So let's get started. Basically, my name is Jakob Lynge. I'm 27 years old, at least a couple of weeks now, more, and I have a Bachelor of Engineering within the field of electronics and computer engineering from 2017. So it's only a little over 4 years since I actually left school. Right now, I work as a senior product development engineer at Grundfos, where I'm the point of contact for MGN drives, which you can see on the screen here. That's my MG, which is an IE5 motor and a control box integrated onto it. And this is our COE range, and that's me. Sorry, I didn't have that better picture because of Corona. I haven't had time to put my suit on in ages. But yeah, then how did I end up in standards? Because it's quite a at times confusing story. I got hired at Grundfos and I started working with my MGs, and all of a sudden I had to do something called DMC testing. And this is a year after I left school, so I didn't know anything about it. And I started, okay, I'm luckily as some EMC expert, I could ask, okay, so what is this and how do I do that? Because I was just looking at something called CISPA 11B and EN 61800-3 limits, and I was like, I don't know where to start here, but I grew a little bit curious about how this was structured, why it was written that way, and what's the benefit and how the process of it all was. Because if I need to test something, I at least need to understand how it's written. And that's why I attended a Danish standard workshop for young professionals in Denmark in 2019. A very good workshop that presented a little bit insight into how these standards was created and what the work was going on and how the different lobby groups might have different points of view to shaping standards. So it's also interest them. And I was chosen to be the Danish representative at the IEC Young Professional Program at the General Assembly in Shanghai in 2019, where I actually met around 110 other young professionals coming into standards that either had no idea what standards was, or they were working for the Australian Standardization Bureau or the Chinese version. And we came in together, and the energy in the room was almost electrifying because we wanted to learn, we wanted to understand. We tried out all of these processes, mimicked these meetings that TC22 had and all that, and it was it's a very interesting way to actually figure out what all of this standardization world is about. And after that, I came home to Denmark again, and I started working the committee work at S522, which is the committee in Denmark for power electronics, where I, amongst other, been commenting on drafts for the 61800-9-1 Norbert talked a little bit about. Amongst other standards, we have been holding meetings discussing upcoming drafts inside this webinar, for example, what to present, how to present it. And it's all in all, it's just giving me more insight into the standards, which benefits my job actually, because what we see over here is actually my MG control box, a motor, and on an inbuilt pump. And it's just, it gives something I can take back to the team. My work in standards may take some time from my other tasks, but it gives something I can get back to my team in the end. I also have done some standard reach and rows directives according to materials for my product. And I've done a lot, even more testing, basically. It's insane how much testing you can do to try and fulfill these standards, and you learn a little bit every step of the way. And now I'm going to talk a little bit more about the specific of testing on the MG I've done. Basically, our MG was developed with an IE5 motor because we wanted to save a lot of energy for the world. We also want in Grundfos to provide clean drinking water, but at least pumps as energy efficient is a step on the way. And basically, we have a range of from 0.75 kilowatts to 11 kilowatts right now. That is IE5. And what's not to say if there is more to come in the next couple of years. Basically, we have my MGE product. It's an enabling product, meaning that we provide it to a lot of these pump types you see here. And what it does is actually we go in and enable ourselves to provide this VSD experience on the pump, and then we can hit the wished functional point and adapt to, let's say, a water facility. It has pressure on in the morning and in the evening. During the day, there isn't that much, so we can go in and stop our pump from using energy at that point to save you energy. And this product is saving energy around the world. And these duty cycles changes and operation modes enables a lot of energy savings compared to our fixed speed drives. That's also a little bit throwback to what Norbert said about saving. If we went the VSD way where it was optimal or could make a difference, we would save 8% of energy in the world. But basically, a lot of things go into making this kind of product. We're doing testing for the 61800 series, which is adjustable speed electrical power drive systems. We are doing testing according to 61800-3, -5-1, -9-2. And all of this goes into development when we do the development. Of course, if we do a variant of it again afterwards, we will need to retest something. But when we are doing development, we are leaning up against these standards to make sure we have a safe product and make sure we have a sellable product. I've been doing EMC tests as well on this, all different kinds of EMC tests, immunities and emissions tests. And we're doing this to make sure we fulfill the essential demands of the EMC drives. We're also doing it to make sure we are not interfering with other systems that is connected to our MGEs or e-pumps at Grundfos. And we're also doing it to make sure we just have a safe product. We evaluate this when we are with locking, with visual and audible inspection, and we're doing function tests afterwards to make sure our product still functions after, for example, a high voltage surge test. As I said, we are ensuring safety through standards. Amongst other that 61800-5-1 that specifies safety requirements. We also doing risk assessments throughout development and also throughout product life cycle to see, do our product actually fulfill standards, and also do it fulfill everything else that the standards not covered, as Preben mentioned earlier. A good example of that is foreseeable misuse. For example, if you say you cannot have this cover off with the power on, but you know that service people will take it off because they might need to do a reading or measurement, then you need to cover this foreseeable misuse through risk mitigation and a risk assessment, risk mitigation, and then say, hey, okay, we have protected are servicemen for against electrical shock, which is actually a IPX2B requirement from the 60529 standards from IEC, which we also test for. We do not test for it, we design for it. We need to make sure our product is safe to handle, so I've also been handling touch current tests, which we measure using this circuit from the 62. Oh, I didn't write the standard down here, but it's specified in the standard that this measurement should be within below the limit of 3.1 milliampere AC or 10 milliampere DC limit. And it's done via, you're measuring it via that circuit. We are also doing designing for wire bending space, which is the table I've just put below here, to make sure that if your product is moving and vibrating, all of a sudden if the wires are tightened too much or bending too much, it might start snap, providing a hazardous environment where you could get electric shock, which we definitely don't want. Now I mentioned a couple of things here from the 61800-5-1, but there are so much more of standards and required tests in here. So I recommend giving that a read if you want to get a little bit more into the knowledge of it. But at Grundfos, my MGs comes from lower part complete, which is put into a motor and complete frequency converter, and then into a pump system. Throughout this assembly phase, we're doing high voltage tests. We're doing a function test of the PCBs and the units, and we're doing a final test where it's put together and have a motor, and we are doing no load tests and all of those kind of things to make sure that what we deliver out of our factory is a compliant product, is ensuring that we live up to all the standard marks we actually put onto our nameplates, which I've taken a little bit of a photo of our IEC nameplate here, where you can see we have a lot of different approvals like the CIUS, the CE, the RCM, the EAC, and you can also see that we have the V directive, but also we have the marking of an IE5 motor and the IES2 system, which is the motor and BSD, as Norbert mentioned. We have this on our product because this we need to in some cases, but also it grants access to have these approvals that's based on standard. It grants access to global market access. So it's something we designed for and something we took pride in fulfilling. Then I'm actually at the end of my presentation. I don't know if that was too fast or too slow, but I just want to highlight why I think standards are awesome to be in compliance with. Basically, it grants easy access to a market. It highlights that you have taken into consideration fault condition and just deliver a more robust design, which in the other end have a higher safety. If you fulfill the categories of the 61800-9-2 like we do, it also means that you have a higher energy efficiency and you will have more energy savings you can bring to a client, which will add on to your value propositions of your product. But all in all, what this does is actually make a difference for communities around the world, for the world in itself, and the challenges we face ahead. Yeah, and then if there's any questions towards my presentation, just write them in the chat and we will pick it up in the Q&A session we have afterwards. Thank you very much. And over to you, Søren.
Thank you, Jakob. As I said, it was a very interesting, very exclusive presentation. It's great to be close to the test laboratory, and you really brought us there. I think I've not been any closer, I think, ever. So it was very, very quite interesting. And please, if you have any questions to Jakob, please write them in the chat. So far, this is where we are heading. Yes, let me see if I can take control of these screens. The next topic is a little bit related, but at the same time, we are also changing application. So from Jakob to Jakob, we are changing application at the same time. Jakob is going to introduce the application himself, but we're going to talk much more about labels on power electronics and what it can mean and where it can lead to. So Jakob from Schneider is going to take the next topic. I have to hurry a little bit concerning the timeline so that Jakob is going to have time enough to explain the entire topic without jumping over some of the things. So Jakob, please introduce your next topic, and then I'll turn the screen to you.
Thank you very much, Søren. Everybody see my screen?
I think it's
Can you see my screen now?
no, not yet. It's coming up. Yes, now it's there.
Okay.
I think.
Yes. Welcome to this presentation about implementation of standards and labeling schemes and their advantage on the world market. First, my name is Jacob, and educated in Bachelor in Electronic in '99. I was working by Schneider Electric as design and test engineer in about 20 years. And today, most of my time is going with compliance of UPSs to different standards around the world. We have different skills about standards, but the picture on your screen show how some of the standards be implemented around the world. We have IEC and ISO. They are used worldwide. ETSI, Senelect for Europe. And in Europe, we have the Danish Standards Institute to take care of the standards in Denmark. And it's here, and I am members of the S522, like the other presenters today. Each country has their own standardization institute. Everybody maybe knows a little bit about Schneider Electric, but the Kolding site has a long history, and today we are a design develop center of all three-phased UPSs worldwide. It's been founded in 1942, and the name was Silcon. And it started with production of special condensators for the car industry. and power converters, AC-DC and DC-AC. And the start of the UPS application started in the 1970s. In 1998, it be changed to American power conversion. And at this time, we were about 530 employees at the site in Kolding. But then in 2001, the manufacturing be moved to low-cost countries, and then we be about 160 employees. In 2007, it be changed to Schneider Electric, and today we are about 200 employees at the site. So we are designing UPSs, and UPS is designed to provide reliability, clean power to a load. Example, IT system in a data center, even in the event of a power failure or disruption in the main power source. Most of the UPS systems do this by performing a double power conversion today. They take the AC power from the main power source, rectify to DC to perform filtering, and also charge the UPS batteries, and then convert the power back to the AC for the load. At the right side, you can see some different type of UPSs. The standard for UPSs, the shown standards are product standards for UPS. The IEC 62040-1 are safety, 62040-2 EMI requirements, 62040-3 performance and test, the -4 environmental aspects. There is also a number 5 used for DC UPSs, but this will we not look at today. As we have seen in the other presentations today from Preben, he has talking about the safety requirements, which has relation to the product standard 62040-1. Norbert about the green transition, and Jacob has talking about EMC and test. I will tell you about using the standard another way now, because when we're following the standards, it also can be used as marketing compared to our competitors by labeling the product to do it more visible for the customer that the product is more green. First, I want to explain a little bit about two types of high efficiency modes called Eco mode, figure 1, and E-conversion, figure number 2. The high efficiency mode is a UPS operation mode for which the primary goal is to reduce the system power loss and increase the efficiency compared to the inverter operation, normal operation, or battery operation. Higher efficiency, smaller loss make the UPS more green, and compared in normal operation, the efficiency is from 93 to 96%, depending on the load. But in high efficiency mode, it's about 99, and in eco mode up to 99 in E-conversion, depending on the load. Common for both high efficiency mode is that the static bypass switch is used for powering the load through the bypass part. The reduced power loss as the efficiency of the bypass part through around the efficiency we have talking about the 98 to 99. But that means that the load is more exposed to unconditional utilities power, and the UPS must then monitoring the bypass power and react on events and transfer back to inverter operation when needed. The difference between the eco mode and the e-conversion mode is that the inverter is off in eco mode, where it's on in e-conversion. In e-conversion mode, the inverter is able to run in parallel with the bypass source by supplying the load and deliver the input power factor close to the units. Another thing that are in e-conversion mode, it is possible to transfer back to inverter operation very fast compared to eco mode if it should be required. So keeping the inverter on in e-conversion mode has a small impact to the efficiency. If we take a look at the IEC 62040-3 test performance standard, we can see in the clauses 5.3.2, the manufacturer shall declare at point A the performance classification according to the clauses 5.3.4. And we can see in the bottom the UPS, if it is a double conversion UPS, it's a classification as a VFI performance. And the UPS we develop today are double conversion, so VFI performance. Let's go to the clauses 5.3.4. The manufacturer shall clarify the UPS according to the following coding: AAA, BB, and CC. The AA are voltage and frequency dependent or independent. The BB is the voltage waveform. CC is describing the voltage variations. The output for performance, it be verified performance, some electrical test on the system, and it's according to the clauses 6.4.xx. You can see in the bottom of the right side of your screen. The list of possible performance classes according to this 62040-3 standard are listed in this schematic. We can see the group for the input dependency classification, the AAA, are voltage and frequency dependent or independent. That gives 3 combinations. The voltage output performance classification BB gives 9 combination, and the dynamic output performance classification CC also gives 9 combination. A summary of the subclasses is listed in the definition group. From the standard, the following curves classify the classes to be class 1, 2, or 3. Classes 2 left and class 1 right. Class 3 is not shown here because it's not interesting today. As shown before, the UPS be tested according to the clauses 6.4, and the results shown that the clauses the UPS will compliance to at the axis we have the voltage dimension and the transient duration in milliseconds. The test result of the UPS has been added in these curves, and we can see the e-conversion mode is inside the limit of the class 1 definition according to the IEC standard 62040-3. A summary of the test and the standards definition. The UPS is double conversion, unlike UPS operating in normal mode, and can regulate both output voltage and frequency. So according to the standard, the classifies coding AAA be classified as voltage and frequency independent, so VFI. The sine wave inverter delivery power to the load in both normal and stored energy modes, so the standard classifies coding BB, B to SS. The inverter continues supplies power to the load during power failure, and because the inverter handles the step loads well, the standards classify the dynamic output performance as 1-1. Then complete output performance be VFI, SS, and 1-1 according to the standard, and it's the -3 from 2021. How can we use this as marketing and make it visible for our customer? We have used the UL laboratory as witness test to verify the output performance was a class 1. The test has been done according to the old standard from 2011, but it's still a class 1 according to the new one from 2021. The difference from 11 to 21 version is the last digit, the 311 changed to 11 in 21. The table number 2 on the screen show the test results of the efficiency measurement from the test that has been done back to 2014. And if we look at the difference between normal operation and e-conversion, we can see the OOPS save power and is more efficiency and green when using the e-conversion mode. The label shown in the right side was designed to be placed on the UPS. If we take a look at the label, we can see the home page in the bottom of the label, verify.ul.com, and type in the number also on the label, the A422015. We get the certificate of the classification. This label has been placed on the product and used to show this product is verified by third party to be a class 1 UPS at the performance output classification according to the IEC standard 62040-3. Yes, it was all my presentation about using the standard to labeling the product on the market.
Thank you very much, Jacob.